The Glaser Method is a simplified approach used to assess condensation risk within building structures by understanding the movement of water vapor. It is crucial for managing moisture-related issues such as mold and decay in building components like walls and insulation. This method is based on the concept of vapor pressure and temperature gradients, which influence the diffusion of water vapor through different materials. Stick around to the end of the video, where I'll reveal exactly how foil placement can make or break condensation performance in wall systems. The primary purpose of the Glaser method is to identify potential condensation points in building elements, thereby helping architects and engineers design structures that minimize moisture accumulation. It aids in selecting appropriate insulation and vapor barriers to ensure the longevity and healthiness of buildings. The Glaser method calculates moisture movement through building components by analyzing the diffusion of water vapor, primarily using Fick's first law, which describes diffusion based on concentration gradients. It evaluates the interaction between internal and external temperature and humidity levels to assess condensation risks. The method assumes steady-state conditions, meaning it does not account for changes over time, such as varying weather or material properties. While the Glaser method focuses on vapor diffusion, it does not explicitly consider other moisture transport mechanisms like capillary action or liquid water movement. This makes it a simplified approach, suitable for specific scenarios but with limitations in addressing more complex moisture dynamics. The Glaser method is widely applied in building design to assess the risk of interstitial condition in walls, roofs, and floors. It is particularly useful for comparing different construction designs at the planning stage. However, it should be used cautiously, as it does not account for all moisture transport mechanisms. The Glaser method has several limitations. It only considers vapor diffusion, neglecting liquid transport and materials' hygroscopic capacities. It assumes one-dimensional moisture flow and constant internal and external conditions, which may not reflect real-world variability. These simplifications can lead to unreliable results if not applied carefully. The Glaser method is codified in standards such as BS, EN, ISO 13788 and DIN 4108-3. These standards provide guidelines for calculating internal surface temperatures to avoid critical surface humidity and interstitial condensation. The method is recognized for its simplicity, but also for its limitations, which are clearly outlined in these standards. For more complex scenarios, advanced hygrothermal modeling tools like WUFI offer a comprehensive assessment of moisture dynamics in buildings. These tools can simulate transient conditions and multiple moisture transport mechanisms, providing a more detailed understanding of building performance over time. Using software like Ubakus can help visualize how the Glaser method is applied in practice. Visual examples can illustrate how different design configurations affect moisture movement and condensation risks, aiding in the selection of optimal building design. So in conclusion, the Glaser method is a valuable tool for assessing condensation risk in building structures. While it offers a simplified approach to understanding moisture movement, its limitations necessitate careful application. For more complex scenarios, integrating the Glaser method with advanced tools can enhance the durability and sustainability of structures. If you want to learn more about condensation, click on this video. And you can find this infographic for free on our Patreon page, linked in the description. Stay informed, stay inspired. TimberTalk.